Hi everyone, our project is the economic conversion of date seeds into oils for cosmetics. My name is Kate.
I'm Dalal.
I'm Shubhi.
And I'm Steven.
And we are team 22081. Date palms are mostly grown in arid and semi-arid conditions around the world. Date fruits have been cultivated in the Middle East and Northern Africa for over 5,000 years, making it one of the oldest food crops ever recorded. The date fruit is composed of a fleshy fruit part that envelops the inner seed. The date seed is a byproduct of date fruit production and is often an economic waste product. Research on extracting the oil from the date seed for use in cosmetics has been conducted as another economically viable option for utilizing the date fruit byproduct. Date seeds contain antioxidants and unsaturated fatty acids that, when applied topically, contribute to the overall health of the skin. The problem we will be solving is finding an economic conversion of date seeds into oils for cosmetics. Our aim is to extract 95% of the oil available in the date seed. And 95% extraction would give an extraction yield of 9.5%, assuming that 10% of the date seed is oil. Since the extracted oil would be used for cosmetic purposes, we wanted to make sure that there was no solvent residue and that the oil did not degrade from a high processing temperature. SFE uses a solvent in its supercritical state where the phase boundary between liquid and gas disappears. This allows the CO2 to effuse through the solid like a gas and dissolve the material like a liquid. CO2 is widely used as a solvent because it is environmentally friendly, non-toxic, non-flammable, and non-corrosive. Processes operated using supercritical carbon dioxide at low temperatures preserve the nutritive capacity of the extracted oil, and the product extracted is pure with almost no solvent residue. These are a few important reasons why we chose to use SFE for our process.
The process starts with a crusher that crushes about 57 kilograms per hour of date seeds. The crushed seeds then fed to a high temperature and pressure extractor. Supercritical carbon dioxide extracts the oil from the seeds in this extractor. The output stream containing a mixture of carbon dioxide and oil then goes through a pressure reduction valve that reduces the pressure of the stream to about 50 bar, where CO2 changes its phase from supercritical to gas. This stream then passes through a flash drum separator, where further reduction in pressure ensures carbon dioxide separates as a gas almost completely from the oil, which is removed as the final product. A carbon dioxide storage tank is used to ensure a continuous supply of CO2 in this process. The stream combines with the CO2 stream exiting the separator. The stream is then heated through a heat exchanger, where the energy of steam is used to heat it to about 40 degrees Celsius. The output stream is then compressed to a pressure and temperature of 250 bar and 60 Celsius. Carbon dioxide is supercritical under these conditions and flows to the extractor to extract oil. For a process, we would require a 60-liter crusher for a feed rate of about 58 kilograms an hour. A high-pressure extractor capable of operating at 250 bar and 60 Celsius is used for extraction of oil using supercritical carbon dioxide. A pressure reduction valve is used to reduce the pressure of the stream, exiting the separator to about 50 bar so the CO2 can separate from the oil. CO2 tank used to replenish the CO2 is stored at 18 bar and 25 Celsius. A heat exchanger with a heat duty of 24 kilojoules per second is used to heat the CO2 stream, and a centrifugal compressor increases the pressure of the CO2 stream to 250 bar, changing it to a supercritical fluid.
Before we run our experiment, we need to crush the date seeds with mortar and pestle and a grinder to have it into a fine powder. And then we crush about 50 grams of the date seeds and scale it. And then we make sure that the CO2 tank is secured to avoid explosion hazards. For running our experiment, the first experiment we ran was for 45 minutes to vary the CO2 flow rate with a constant temperature and pressure. And then the second experiment we ran was for 19 hours. And then the last one was for 55 minutes. All of these experiments, we weighed 50 grams of a crushed date seeds and secured into a metal mesh piece. And then we close bezel and charge the CO2 to the system as for a flow rate 50 grams per minute, setting the pressure at 83 bar. And then we allow the circulating water bath to run to reach the steady state of a temperature 60 Celsius. Once it's reached the supercritical fluid point, we begin record the time. Once the time passed, we depressurize the system and allow the CO2 to escape as vapor. Then we drain the oil from the bottom of the nozzle into a beaker just to collect our sample. Then we weight the sample, the yield. We repeat all these steps for varying the residence time, CO2 flow rate, and then the temperature and pressure. We run one more experiment, the Soxhlet extraction. It was 3 hours, and we got a solid phase oil, about 1.7 yield of oil.
So our team believes that there should be more research done on SFE with CO2 before moving into an industrial scale process. The extraction method is very sensitive to changes in temperature, pressure, and particle size, and has a different set of optimized conditions for each unique solid matrix, which would include more resources and more testing. In addition to that, the oil was extracted in a laboratory scale, or the oil that was extracted in the laboratory scale was in a solid phase, which may not be desirable for use in cosmetics. With solid oil, the process may have to include additional steps such as fractionation. A few solutions that we would like to propose for further research would be to do extensive testing to find the solubility maximum for the date seeds to determine the optimized CO2 flow rate, which would reduce the raw material cost of the process. In addition to that, adding a polar co-solvent has shown success to increase the yield of oil in SFE. Success has been shown in coupling SFE with ultrasound-assisted extraction as well. And these are some things that we find important to investigate before investing in a full-scale supercritical fluid extraction of date seed oil for cosmetics. And we would love to give a special thanks to Mahmoud Dako, who is our mentor, and then also Douglas Loy, who is a professor in the materials science and engineering department, and Kevin Frederick, who is a postdoc at the materials science and engineering department at the University of Arizona. And here are our references. And yeah, thank you. We are excited to see you at Design Day.
Thank you.